My name is Shaun Ruffell, and I work for Digium, and I'm a Linux kernel developer there, and I work across basically on all the Linux platforms that Digium ships. And my talk is going to be about styling and profiling your Asterisk install, but I don't really have a good personal sense of style, so it's really more about just profiling your Asterisk install. But profiling isn't specifically what I'm going to be talking about. I'm going to be talking about tracing and how tracing, you can get the same information you can from profiling by tracing. So it's really tracing your Asterisk install, but then if you throw on WebRTC, you get a big crowd. So I'll say tracing your Asterisk and WebRTC system. But really, it doesn't have a lot to do with Asterisk specifically. It's more about just the Linux Trace Toolkit and what tracing can tell you about what your system's doing. And it just happens to be beneficial if you're running an Asterisk or a WebRTC system. But I have bad news. Through personal and professional failings, I've misplaced in my slide deck and deleted the slides that I have. So I'm just going to basically tell the story. I still believe I can convey what I wanted to convey, which was why this is cool. And if one person gets excited about it, then the presentation's a success. But having said that, it's going to be a little rough. So if anyone wants to go to one of the other presentations, it won't hurt my feelings if anyone does. And I'll just post a blog post about this and get it up on Digium's blog before the end of the year. So I have the picture of the supercoder up here because when I don't have my special keyboard, my live demonstration typing skills are kind of rough. So just bear with me. So I just thought I would talk, pass out the virtual hot cocoa, and tell you about why this is important to me. So I've kind of had three major epiphanies in my personal life, my professional life. One time I remember walking through a bookstore and seeing the Asterisk, the definitive guide, and at the time I was kind of the system administrator, the kernel developer of a small startup, and we were paying some Nortel guy $75 an hour every time we hired somebody new or changed the extension. And when I saw that Asterisk book on the bookshelf, I had this, oh man, that's really awesome. That could really be beneficial to me. And so, that was one kind of really exciting moment I had. Another one is when I first came across Git and started using it to, specifically, the first thing I wanted to answer with Git was, when did an interface change in the kernel? So when I was maintaining drivers and making sure I was compliant with certain kernels, how to do that. And Git allowed me to do that. And I was thinking, I was really excited because I could tell it was going to be the new hotness, and if I learned it quickly, I could lord over my colleagues with my knowledge. Yes. And the third kind of epiphany that I had is when I first came across the function tracer in the kernel. So in about the 2.6.20 kernel area, they added a way to kind of dynamically place trace points in the function of the kernel for extremely low, at extremely low overhead. So with microsecond overhead, I could basically just kind of add trace points into the kernel and really see what the drivers were doing. And before, a lot of times when you had performance issues, you either just kind of guesstimated or you hooked up a logic analyzer and drove an LED or something like that to see it on a scope. And it was an epiphany. When I saw that tracer, and now I can get nanosecond timing resolution. I can see what's in the kernel, low overhead. It was awesome. And I remember talking to one of my colleagues, and I said, I really think working in the drivers and in the kernel is easier than working in Asterisk because there's all this infrastructure that just kind of makes it easy. You have lock dependency checking for free. You have memory leak checking that you just kind of build in. You have these tracing toolkits. All these things you can do just kind of for free. And it was really, I remember when I really read that article, that Linux Weekly News article that talked about the secrets of the function graph tracer, having that feeling. And so when I was thinking about other Astricons that I've been to and what I think other people might benefit from, I was thinking, well, some of these things that aren't directly related to Asterisk, but that everyone kind of has to deal with at a certain level, I thought would be beneficial because I don't think it's common knowledge about some of these new things that are coming out in these newer distributions and newer kernels. So that's why I decided to talk about tracing. So let me show you the function graph tracer really quick. I'm going to be bouncing back and forth between my terminal. I have a virtual machine running here. But this is just a VirtualBox instance that I have running. And I'm in the sys kernel debug tracing folder. And does anyone not know what the system file is in Linux? Is there anyone who does not know what that is? Perfect. Okay. So is there anyone who knows Raise your hand if you know what the function tracer is. Okay, 1. Okay, good. So, oh, 2, 2, 2, 3, 3. Okay. So in this debug tracing folder, the kernel has, like, this is just a stock Ubuntu kernel, and you can see that they have these default tracer built in, and one of them is the function graph tracer, and if you enable it, function graph, set that to the current tracer, echo 1, tracing on. Now you can cat this trace pipe, and you get all this information about all the functions that are happening in the kernel with their timestamp and information. And this is, I mean, it's just, for me, it's awesome. So I really love it. But, oh, yes?
You want to take pictures as you go along?
Yeah, that's great.
I mean, that must take quite some effort for the kernel to produce that. So you see the effect of that?
You do. As you, where you get an overhead is, well, now I'm talking about the function graph tracer, but as you get overhead is as you go deeper and deeper, each one is, so like maybe 5 nanoseconds, but it adds up the deeper your call stack is. But if you have an ability to, filter just the functions that you want to see. So if you echo one of these trace points into the filter functions, then you can only look at just the information that you want to look at. So that's one of the key points about all these new generations of tracing is it's extremely low overhead when you don't have the trace point enabled, and still highly efficient when you do have the trace point enabled. So so I'm going along and I'm reading the kernel or reading the mailing list and following along with this. And a lot of the people that are extremely active in the kernel space on these tracers have been moving the technology up into user space. And then that's when I said, now I could start using it with Asterisk. So it's not quite as efficient as this with the Linux Trace Toolkit next generation, because you still have to instrument the code. But soon you'll just be able to dynamically attach probe points in your user space applications and trace your user space just like you trace the kernel. So that's why I thought this could be useful for some. So as I rush through this, if one person says, yes, I think I could use that, and that might be good. And the reason, like, how do you debug your Asterisk systems now when you have performance problems? So you use top, you look at it. Anyone use IOTop to see anyone not know what IOTop is? Do you flush your file system buffers to check your disk performance, your disk read times when your file systems? I mean, so there's these things that you can do, but you have a candle here, a candle there. You're kind of piecing together all these various clues. But with tracing, you can actually go in and see exactly what your system is doing without incurring the overhead of putting a bunch of printf statements or asterisk log messages in your kernel. But currently today, you still have to instrument the code in order to do this. So let me go ahead and show you what a kernel trace looks like now. So if on this virtual machine, using the Linux Trace Toolkit visualizer, Vagrant, Asterisk config, and in this, I have this little script here just to basically run a basic test. And so the first thing it's going to do is it's going to, can you guys see that? Okay, do I need to enlarge it, or is that good? So the first thing that you want to do is you want to create a session. And so when you create a session for the Linux Trace Toolkit, what it's doing is it's basically starting up a daemon that's going to be listening for connections from other processes on the system. And so that's the process that's going to collect the information from the kernel, the other user space applications that you want, and it's going to know where it's going to write the actual eventual binary trace files out. Because these trace files that it's collecting are very efficient. They're in a binary form. They don't do any integer decoding until the actual time that you go and read them. So that's very efficient. Then the next thing you want to do is you want to tell that daemon for the current session which events you want to enable. So in this case, I'm saying enable all kernel events, and actually this is a typo. I'm enabling all kernel events, and then in this next line here, I'm going to say go ahead and enable all the user events. So if you had your Asterisk or your AGI script, well, I guess in this case it wouldn't be a script, you'd probably write it in C. if you had those instrumented with trace points, you could go in, dump the available trace points, and then just turn on the ones that you wanted through this thing for each individual session. So you don't have to recompile. Once you have your code instrumented, you can just keep those patches forward and instrumented. So then once you go ahead and start the tracing, now all the information is being collected from all the different data sources on the kernel that are being generated. So in this case, in this test, then I just go ahead and start up Asterisk. This is this hello file here is a sample file that was distributed with the Linux Trace Toolkit Next Generation that actually has user space trace points, because I don't have my version of Asterisk that had the trace point, the instrumentation on it. And then I just wait for it to be fully booted, and I stop, and then I shut down the trace session. So I'm going to go ahead and run that now. And I really hope you guys think this is cool, because it will be validation that I'm not a weirdo. I'm sorry? Oh, thank you. I should have been reading what RX. All right. So it's going. This hello world basically is just going in a loop and just collecting trace points just so you can kind of see it when it's mixed in. And I'll open that up later so you can see what the instrumentation looks like when you're instrumenting your user space process. And one thing, when I was preparing this, I'm running this on a virtual machine, and one thing that I can't answer that I was like, oh, I wish I could answer this, but I can't, is I still have to do more research to investigate when you have your host platform perturbing your virtual machine, what kind of effect that has on your trace timestamps. And I know there's people doing research on that right now. I just didn't have a chance to go and investigate that. But this is running on a virtual machine right now. It's running for a long time. Let me take it without the joys of the live demo. I'm going to stop Asterisk and run it without the user space. Okay, so comment that out. I'm just going to, so basically this is just going to start Asterisk in the background, wait for it to be fully booted, and stop it. Okay, so now the trace run, and in the output that I specified in the session, I have the trace file saved. So now what I can do is, unfortunately, that's interesting. I can go ahead and load it up in Eclipse, and let me just go ahead and load up the one that I just took. And the visualizer for the trace is in Eclipse right now, and I'm not a big Eclipse fan, so they have another one that's written in GTK has GTK front end, but they haven't updated that for the new 2.0 tracing format, so that's why I'm using the Eclipse version. But the visualizer is quite nice. So I'm going to go ahead and delete the two traces that I had loaded up from before I really messed myself up and deleted everything. And I'll go ahead and import the ones that we just took. So it's just the kernel one. That's the only one that I took there. And then I'm going to go ahead here and say that it's actually a common trace format kernel trace. And the Linux Trace Toolkit Next Generation guys, they're really pushing this common trace format, because as GDB already produces a trace file in the common trace format, and as more and more tools use it, then they can just be one standard set of visualizers that know this format. So I'll go ahead and load that up. And then now we can look at it in the, oh, that's my problem. I got this. Okay. So what we're seeing here is, on the bottom is the histogram of all the events that were generated, and this is a detail view. And in the top window, these are all the events that, after they've been converted from their binary to their textual form. So this is one way you can look at it. So now, say you had your Asterisk install instrumented, the kernel events and the user space events will be interleaved. And so now where you can really see the power of this is when you actually use a visualizer that knows something about the trace points that are being collected. And Let's see, as it's finished loading up. Again, it's Eclipse, Java. Any Eclipse fans? Good, all right. Where's Matt? I know Matt. He was an Eclipse fan, right? I think so.
So is it reading the file in right now?
It's reading it in, and it's converting it and indexing it, yes. So because it tries to keep most of the, okay. So here are the two views well, this view's not up yet. Oh, man. I swore this just worked like an hour ago. Well, let me look at the other window while this is going up. So this is, when you're looking at the kernel trace, what does Eclipse call these? They're perception. Anyway, Eclipse has a name. They have a name for everything. They have a name for these views into the data. So up here, there's like a tracing view, a C++ view, and this kernel view. And so the kernel view knows about the actual kernel trace point, so it can give you a visualization of what's happening. So in this virtual machine, I only have one CPU. And so you can see here on the CPU, if I drill into it for any particular point in time, you can see exactly what that CPU was doing. So here, it was the LTTng was calling splice, and that's the system call to feed the data to the visualizer. But let me go back where the Asterisk should be running. It's easier if I can see it here. Okay, here we go. So this is in the control view. You have all the processes on the left there, and I can go to where I started the Asterisk process. And I said I can go to where I can start the Asterisk process. Oh, lordy, 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 lordy. Okay, so here's an Asterisk process. So if I go over, I get for running all these virtual machines on this notebook with a Java program. Well, I guess it's just it's a day of fail for me. Day of fail. Something's wrong. So, well, okay. Well, I guess I'll just tell you what it had showed me previously, and what I wanted to express is that you can kind of see you can see the different threads in Asterisk bouncing between CPUs. You can see what system calls they're making. You can see when they're in a futex, when new processors are cloned, and what they're blocking on. Here, what I'm interested in personally is you can see when Asterisk or any user space process, when it gets on a certain CPU, when it gets interrupted by an IRQ. So here you can see like the IRQ, which is the disk IRQ, started running at this point that I'm zooming in on. And when this catches up here, so you can, as I drill in here, here we go, as I drill in here, you can see that find was, that's my problem. I'm running find in a loop in the background because I was trying to collect another sample. Well, I'll do that later. So you can see that the process find was running here, and that here it was interrupted by a disk activity. And I was actually trying to collect another example that I could show here earlier to show you that as how disk activity and misses on the file system cache actually impact process performance. But I mean, I think this is really cool. I know the presentation is clumsy, and I apologize for that, but this is awesome that you can then open up this holistic view onto your system and see everything that was going on from task to task, and it really will take the guesswork out of when you have real performance problems, and you want to know, like, is your system blocking because you're in the networking stack doing retries? Is your system performance suffering because you have extra slow disk or because you're missing your file system cache? This is now a tool to show that, and I guess I will open it up for questions as I stand up here completely mortified, I have to say.
Shaun?
Yes.
So, O profile can give you quite a nice big picture of what's going on in your system, especially if you can get the symbols out of the applications. And then this can go right into the gory detail.
Yeah, the different O profile is a great tool, but it's based on sampling. So that's also another problem with top, because a lot of the times people get those the process utilizations at top, but those numbers are only generated by samples that are taken when the timer tick fires. So it's whatever happened to be going on in your system when that timer tick fired, that's what you see on top. And where that bubbles up to me in my job at Digium is that a lot of times people will say, I'm seeing odd performance, which is based on the interrupts preventing the timer from running and changing the statistics that you're getting from top. So O profile has some of those same issues. And so, like, fundamentally the difference between profiling and tracing is that profiling, you're just basically taking frequencies of events and average times of events, where tracing is much lower level, where you want to just know every state transition that happened, and then you just do it all in the post-processing. But O profile is awesome. Another tool, I mean, there's like a battle royale amongst the user space tracing tools right now. Linux Trace Toolkit Next Generation is just one. There's also dtrace, system tap. There's other mechanisms to do user space tracing, and so this is all kind of being shaken out right now. But I think as more and more people start actually using the tools, there will be only one winner at the end. So, yes, Tori.
If I understand your LTTng example, well, the instance that you do LTTng start, it's dumping everything that the kernel is doing from that moment on to a log file.
Yes, into a binary, in a binary form. And the way that it does that is it uses a shared, well, for the kernel it uses the splice system, so it opens the session daemon. The session daemon has a way to write to, has the file open, and then it tells the kernel will splice right into that process, so it's no copy. So it's as efficient as it can be, and you can also stream it to another system if you want to.
Is there a way to filter it to just show the calls that were initiated by a call from the Asterisk process?
Yes, when you enable the trace points, you can actually filter on fields in the individual trace points. So you could enable it and say only with the process name of Asterisk, and then you get all Asterisk process and all the threads and stuff like that. So.
Once you get this set up, is this all dynamic? Like, your Asterisk system is down, you have no idea what's going on. You can set up some of these and kind of see what's going on.
You'll have, for Asterisk, if you want to, for the kernel, if you're using a new enough, if you had it running, it'll work. It'll work. For Asterisk, you have to make sure the trace points are compiled in, and then when they're compiled in, you can dynamically turn them on or off. And one feature that's still on the to-do list that I'm personally looking forward to, which the ftrace, the kernel function graph tracer gives me, is that they're going to have a flight recorder mode. So basically what you do is you just turn it on, you add the trace points that you want to watch, and it'll constantly collect. And then when anything happens, you can say dump it now. Or if the process crashes, you can get the trace dump because it's not in the same process as Asterisk. So flight recorder mode, I think, is the big push for the next thing that'll really make it in production. People just leave this on and leave it running for. But right, like if you have a problem with Asterisk and you didn't do any work ahead of time, it's not going to help you in that case right now. So does anyone have any tomatoes they want to throw or anything? Oh yeah, WebRTC. It's awesome. It does video. You can use it on your phone. It's really cool. But it still runs on Linux and Unix-like operating systems, and everything that pertains to your base platform is going to be pertained to your. you can't keep making levels of abstraction and forget about the fundamentals. And actually, actually, let me plug this book. Let me plug this book, right? I gotta. This guy, when I was doing my research for this farce of a presentation, I found a blog by this guy Brendan Gregg, and he wrote this book, and it's actually not out yet. It's coming out in October 17th. And I wrote him, and I said, I think that based on everything I said, I think this book would be really highly pertinent to anyone that would come to this presentation. And he was kind enough to send me a link to get an early copy of it. And I looked at it, and I do think because not only does he's specifically talking about using dtrace, which has slightly less, it has slightly more overhead when you're doing your tracing. But he really kind of goes more than I did into how the whole process of troubleshooting, like how to decide when you want to use tracing and how you do your triage. And then once you get to that point, then he talks about how using dtrace to look into that. So if you're struggling with specific performance issues, I highly recommend picking up this book. But what I was going to say about, now I forgot why I even brought that up. It was directly related to something that, anyway. Because that's the point. The company that he works at, they do cloud platforms, and what he said was that for him, this is becoming more and more important because as people pay for CPU time by like the minute, now it's not like, oh, I sunk a cost into a bunch of servers. Who cares about performance? It's like, hey, if we can like increase our performance and reduce the computer, that's savings that we can realize soon. So he's saying more and more people are looking into this as a direct cost savings because of the move to the cloud. And all right, well, thank you very much, and I apologize profusely.